Uh, Sometimes the water, when it is very cold, that water also cannot be given for the plant. Like in the ice minus degree, that much cold water cannot be given for the plants. In that case, it needs to be heated little amount. So it has to come to that normal temperature. Only then that water can be supplied to the plant. So there again we will be using some heating system. Okay. So heating system can be of anything. You can use gas or electric heater, or under the ground also the heater can be deployed, and from the ground the water what you are getting, that itself can be warm. That water can be irrigated to the plants. Okay. So heating system. So when the heating system is utilized, obviously cooling system is also required. Suppose you are in a condition where it is extreme hot. Okay, extreme hot. So that also cannot be bearable by the plants, and that is where we require cooling system. So we don't put any air conditioner and all here. So proper ventilation must be provided for the greenhouse. So cooler the atmosphere, to cool the environment, we use proper ventilation. Okay. So again, when we talk about ventilation system, since we are the one, we are designing our greenhouse. It could be the roof ventilation or side kind of window ventilation, can be anything. Okay, kind of grill can be utilized to get the proper ventilation. These systems are utilized to cool the environment. As we are trying to control the environment within the greenhouse, these are all the systems we are using. So next, irrigation system. Irrigation system. So we have discussed enough about irrigation system, but coming to greenhouse irrigation system, as it is close to thing, and you may grow mixed crops. You may grow mixed crops, like when what do you want? So when you are taking some 2 or 3 acres, definitely there will be a crop which will be a long-term crop also. It may be a coconut tree or mango tree, something trees kind of thing also can be grown up. So in the field, in the farm, maybe in the sidewise you can have a tree, or in between trees can be kept, and all other places are covered with some other crops. What I am trying to say here is, you are growing a mixed kind of crops. Some crops may require only 3 months duration. Some crops may require 6 months duration. Some crops may require more than a year too, depending upon the duration what the crop is required, or the type of crops. We will be using different irrigation system. If you are going with the rice crops, obviously we go with surface irrigation system. Greens or some vegetative plants, we go with drip kind of irrigation or sprinkler irrigation. So what sort of irrigation you are going to follow, that needs to be chosen according to the plant and the stage of the crop. Stage of the plant, like when it is in the earlier stage, younger plant, you use a kind of irrigation. When it is grown up, you can use different kind of irrigation. So what kind of irrigation you are following, that is also important in the greenhouse. So next, environment control system. Environment control system. As we have spoken about all other environmental factors like temperature, heat, and I think I listed here humidity control. Humidity is also very important factors to be considered for any living being's growth. Even for us, if you consider when it is extreme humidity and the hall is fully engaged, too many people are there in a hall, and too much humidity, in that duration you feel very difficult for breathing itself. Suffocation will be there. Okay. So same thing will happen even for the plants. So we have to measure the humidity properly accordingly the supplemental support should be given. And environmental control system which covers everything, your temperature, heat, humidity, and moisture, covering everything only we say environment control system. In addition, very importantly, carbon dioxide. CO2 is very important for the crop growth. So here we need to see, because in the natural atmosphere may get a sufficient CO2. If not, in between or somewhere or sometimes some crops will die. We will not be able to analyze why it is right, why the yield is not so good. Since we are exclusively establishing a greenhouse for the plant growth, we even have to consider about the amount of CO2 required by the crops and the amount of CO2 available in the nature. Accordingly, we need to produce additional CO2 and provide to the crops. Okay, so these 7 are the very important thing needs to be considered when we are establishing a greenhouse. Fine. So now I would like to extract few points from you. What would be the challenges in establishing a greenhouse? Satish. Yes. Yes. It will be costly. The initial cost will be too high, and even after that also, till you complete the trial period, it will be highly challenging only. Okay, because we are doing it for the business purpose. If it is for only a single house or a family purpose, or it is in the small scale range, it will be fine. But when it is for the business, of course, the trial period will be very, very challenging. Each and everything you have to measure, and accordingly you have to provide. Even artificial lighting system also, what kind of light is required, what are all the different combinations of lighting we have to support for the plants. As we are mixing, we are growing combined type of crops, we need to analyze the requirement of the crop only. We have to provide correct amount of lighting, not only lighting, heating, everything. So of course it is costly, but once you are familiar with that, then it will be more beneficial. Advantages when we talk about, definitely it is you are able to extend the growing season, right? Normally within 3 months or 6 months that crop is done, you cannot make use of it. But here with the support of greenhouse, year round, all the 12 months you are able to get the yield, or you are able to get anything throughout the year. Not only that, you will be able to move your plants from one place to another place. In such a way you can define or design your greenhouses. Okay, and last class is about space efficiency. Within a short amount of space, you will be able to get double the amount of yield. These are all the advantages. Disadvantages, cost wise it is disadvantage, and suppose you cannot involve on everything as a single person. Whoever is going to be involved in that process, they need to be educated well, because you are deploying various sensors to measure soil health, nutrients level, water management, everything. So they need to have much education, and they need to be updated then and there. Okay, and some natural thing happens unexpectedly. You may not predict that may happen. So that situation also has to be handled properly. For that, proper training must be given to the people. So these are all the challenges when we go with the greenhouses. Okay, fine. So next, coming to crop growth management in the greenhouse. Can you please stop the greenhouse? We take care in this. What will happen suddenly? Where I need to focus more on? What are all the things managed or maintained properly? First thing, climate control. Whenever there is a change in climate, see, it is a summer. Suddenly during summer, few days are raining. That is unexpected thing. That is unexpected thing. Okay, and sometimes the summer is becoming too long. You expect the summer to get over by June itself, but it is getting extended till July. That is again, unlike last year, it was not like that. But this year it is happening. But I established my greenhouse last year having these kind of expectations. But suddenly when I move on to the next year, there is a change in climate. There is a change in weather. So I need, whenever there is a change in climate or weather, I should be in a condition to handle that properly. When there is a change in climate, what are all the changes happen? Heat, change in heat, change in temperature, change in humidity, change in moisture, change in mist, because we even talk about aeroponic and hydroponic plantation and all. Aeroponic means what? Vimalka, now answer me. What do you mean by aeroponic? No idea. This I had addressed in the last class. Aeroponic planting or forming crops. The crops which are grown in mist or foggy atmosphere, like your lettuce or cabbage, broccoli, these kind of things will be grown in the foggy or mist atmosphere only, which will not be normal everywhere. That is the reason those things will be grown only in certain regions only. So when we are growing that, okay, in our place, so the required amount of fog or mist should be produced artificially and provided to those. Okay, so whenever there is a climate change, definitely there will be a change in mainly heat, temperature, humidity. Okay, so then and there it will be changed. So you have to very much keen on that. Accordingly, you have to change your system. It is not like once you set the system, see, I fix the fan, whenever I switch on it will run. There is no change in that. Okay, I don't have to worry about it. But here in this system, it is not like that. Whenever there is a change in the climate, I have to make some changes to the system too. Again, lighting. Yes, okay, I have set up all artificial lighting systems. I have to, suppose if you are going completely a smart farming, I have to program in such a way that whenever there is a change, like even the same plant or on various stages, it requires various kind of light spectrum and various amount of temperature. Okay, suddenly you expect during February, this is what the temperature can be received from the nature, but unexpectedly you are receiving more temperature from the sunlight itself. That is the case, this artificial lighting should be reduced or it may not be required even. Do you understand what I am trying to speak about? Okay, so when you are getting due to the climate change or weather change, when there is a change in the natural resource, accordingly you have to customize your artificial things within the greenhouse too. That may be your temperature or the heat or a humidity, right? So that thing we need to take care. And then irrigation and water management. Irrigation and water management. You would have set up your system that every morning you have to do a surface irrigation. But that particular period of time there was a heavy rain. Again, when there is a rain, it gets rainwater itself. If you are again switching on that system, it automatically supplies the water to the plants. It will be unnecessary, and not only unnecessary, but it will create a problem for the plants. So it cannot be completely fixed. There must be administrator. There must be a person to handle all these things. Okay, technically for each management we must have a people. Okay, we must take care of all those things. We are talking about crop growth management within the greenhouse. Within the greenhouse. Suppose if it is outside, like there is no greenhouse, traditional farming method, no? Night full it was heavy rain, and day full which is hot, very hot sunlight, so there won't be much problem for your crops. But since it is within the greenhouse and you have used a material to preserve the temperature, and again that also will be given to the plant, like you have set everything artificially. So you have programmed in such a way that in the time this is what I am supplying to my plants. After when there is a change in the nature, it will be a problematic thing. Okay. So next, coming to nutrient management. Fertilization and nutrient management. So again, due to rain or some other reasons, the lands will get automatically some fertilizers. Okay, but when we talk about greenhouse, you have to check the condition of the soil, nutrients of your crop. Based on that, you have to supply periodically. So that checking should happen periodically. There must be a responsible people to check and feed the crops properly. And another unexpected, unpredictable thing could be pest and disease. Pest and disease. If it is outside, we say normally, even clothes also, when we are not well or even during COVID and all, you wash the clothes and put it in the sunlight so that we believe that bacteria or virus, whatever it is, the germs will be died when we put it in the sunlight, because it has got that much power. The radiation what is provided by sunlight, the different spectrums of sunlight has lot of power to kill all these germs. Similarly, even in the lands, in the traditional farming system, some kind of pest and all will be killed automatically by the sunlight. But here you have protected your plants from the direct sunlight. Am I right? So in this case, if it is a kind of pest which can be killed by the sunlight, stop over here. And you need to measure that, and then you have to kill the pest, or you have to take the immediate action to avoid getting affected by any of the diseases. Got it? So the next topic would be simulation of CO2 consumption in greenhouse. That logic you can understand, right? Because I am utilizing more space and I am extending the growing season, and I am trying to grow a crop which is not possible to grow in my region. Okay, so in Chennai I cannot grow apple, but still I want to grow apple tree. I am trying to, that is not possible. I don't say not possible, naturally it is not possible. By controlling the environment, I am trying to do so. So when I do so, I have to provide all the required things for my crops. In that, the very important thing, heat, temperature, humidity, that is all okay. But CO2 externally and create and give it to the plants. Okay. So here we are going to see one of the simulation of how the greenhouse consume CO2. Okay. It is a process actually. Kindly make a note of it. Simulating CO2 consumption in greenhouse involves simulating CO2 consumption in greenhouse involves modeling and dynamic interactions between plants, modeling and dynamic interactions between plants, the environment and CO2 enrichment systems. Environment and CO2 enrichment systems. So this, why we are going for this simulation, or we are trying to understand the modeling and interaction and all those things to optimize or to maximize the CO2 level, in turn maximize the productivity, improve the yields. Okay, so for that sake only we are trying to simulate CO2, because when we are able to feed properly to the plants, will give better yield. That is our belief. So for the simulation we follow few steps. Steps for the simulation of CO2. First step is define the parameter and initial conditions. Define the parameter and initial conditions. What could be, it is not like your maths or something like that. Just logically think. You want to check what is the amount of CO2 available in the greenhouse. Okay. Then what you will take as the next step. What is the amount of CO2 generated? Okay. Suppose they more than, required amount of you try to optimize the thing. That's it. So you check what is availability and you generate it and then feed it. When you have generated more, you store it somewhere and then later period of time you will give it. Or for a particular area it is more, another area it is less, now you try to streamline the system. As simple as that. Okay. That is what we are going to see in different terms. So number one in this, you have to measure all these things. First you must know what is the size of my greenhouse. What are all the crops are grown. Each crop, the amount of requirement by each crop. All those things we have to see. So the first thing, greenhouse dimension and volume. I must know greenhouse dimension and volume to measure what is the amount of CO2 required for that greenhouse. Okay, first thing, I must know the size of greenhouse. Number two, number and type of plants. How much crops I am growing and what are all the different types of crops I am growing. Because as I mentioned, each crop's requirement vary. Okay, first thing, what is the size of my greenhouse. Second thing, how much amount of crops I am growing, what are all the different types in that. Third thing, initial CO2 concentration. Initial CO2 concentration. Initially, before I could plant any crops within my greenhouse. So what is the initial CO2 concentration in that particular greenhouse? Next, environmental conditions within the greenhouse. Environmental conditions. So when we talk about environmental conditions, it includes temperature, heat. What is the third one, Mukesh? So when I say environmental conditions, there are three things should come to your mind. Temperature, heat, humidity. Temperature, heat and humidity. So that also needs to be measured. What is the amount of thing within the greenhouse? We are not worried about outside the greenhouse, within that. Next thing, photosynthesis rate of plants. photosynthesis rate of plants. What is the percentage of photosynthesis taken place within the greenhouse? Photosynthesis rate of plants. Next, CO2 enrichment system specification. CO2 enrichment, which means average படிப்போம் ரெண்டு தடவை சொல்லி கொடுத்தா we will be able to pick up, right? Some people மூணு தடவை சொல்லி கொடுத்தாலும் I will do like that. How much I can take it? That is what is enrichment. This much amount is available. If I feed it, whether it will be able to enhance itself, accept itself. Okay, that is CO2 enrichment level. If I feed, if I do something artificially, will it be able to accept it effectively? Will it function efficiently? Okay, so that is about CO2 enrichment system specific. So here I will be how I measure that flow rate and then distribution to the plants. Okay, how it flows. As I mentioned, in one area there are more CO2 level, in another area less CO2 level. I want to stream like that. Like I want to pass this to that, whether it flows properly to the other region, whether it gets distributed evenly to all the plants. So that comes under CO2 enrichment specification. Okay, fine. Second step. So first step contains all those things, defining parameters and initial conditions. Second step is model photosynthesis and respiration. Here only I am going to model the photosynthesis. I am going to simulate it. Model photosynthesis and respiration. Before I could establish everything, I simulate. Only then I take a step to establish it. So model photosynthesis and respiration. So two things we consider here: photosynthesis rate. Photosynthesis rate. So based on that only I understand that this is the amount of CO2 needed by the greenhouse. Okay. So how do I do that? Photosynthesis rate normally depends upon the light intensity. Photosynthesis rate depends upon light intensity and CO2 concentration. Two factors affect photosynthesis rate. Okay. So by using that we have a calculation. P is equal to P max. P is equal to P max of 1 minus e to the power minus alpha I into C minus C min divided by C optimal minus C min into T minus T min divided by T opt minus T min. So this is the formula to calculate photosynthesis rate. Take down that photosynthesis rate is calculated or measured by this formula. Photosynthesis rate is equal to photosynthesis maximum of formula C minus C in carbon dioxide, minimum carbon dioxide, optimal minus minimum, and this is about temperature. If you want to take down that also, where P max is equal to maximum photosynthesis rate. Maximum photosynthesis rate, alpha light use efficiency. This alpha is because you require light for the photosynthesis. So light use efficiency, C min and C opt, minimum and optimal CO2, minimum and optimal CO2 concentration, T min and T opt are minimum and optimal temperature. Two rates we will be considering. One is the photosynthesis rate. When we are modeling this, we need to calculate two rate, photosynthesis rate, and other one is respiration rate. Respiration rate. Formula for respiration rate is R is equal to R base of second step. So first step you need to set up all the initial conditions. Second step you have to model photosynthesis and respiration where you will be measuring the photosynthesis rate and respiration rate. And the third step is CO2 dynamics. That is, you are able to streamline the CO2 or not. Whether the CO2 is able to be, you are able to make CO2 to flow from one region to other region. So that is about CO2 dynamics in the greenhouse. You have certain things here also, few more points. In the dynamics of here, it consists of few factors. Number one, CO2 consumption by plants. CO2 consumption by plants. CO2 consumption by plants. How do I compute the CO2 consumption? Delta of C plants is equal to P minus R, photosynthesis minus respiration into plant area. Okay, so how much CO2 can be consumed by the plant is computed like this. Second, CO2 addition from enrichment system. CO2 addition because you have an enrichment system. From that you try to feed some CO2 to the plants. How do I do that? Formula for that: CO2 delta C enrichment is equal to enrichment rate into time span. Enrichment rate into time span. How much I am able to give? Like, if a patient is there, you are giving a treatment. Sometimes even if it is pressure or sugar, whatever the medication is, even also it will not be under control. Or some patient will be able to take the medication immediately, it will be under the control. So in the same way, even if you are producing from the enrichment system, how far it is able to accept it. That is about this. Next, CO2 exchange with outside environment. CO2 exchange with outside environment. When CO2 is very much available outside, how we are within the greenhouse, it is generated more. How do you exchange with the outside environment? So these points alone you know down, no need to write the formula. Then update CO2 concentration. Update CO2 concentration. Update CO2 concentration. C nu is equal to C current. That is current CO2 level plus CO2 consumed by the plant plus enrichment rate. This all together plus C exchange. This is the simulation of CO2. That is, when you are generating a new CO2 to the greenhouse, all these things will be considered, and that is what is considered as a generated CO2 for the greenhouse. So these things will be done iteratively